let's get started. Let me switch screen. Perfect. Does this work? Yes, that did. Okay, so our first math problem today is how many centimeters is how many milliseconds is in a second? So we're converting milliseconds to seconds. Note that the prefix milli in the metric system, it means a thousandths, or like a thousand, or thousandths. So you would know that there's 1,000 milliseconds in a second. So 1 second equals to 1,000 milliseconds. And 1 millisecond would equals to 1 over 1,000, or 1 over 1,000 seconds. So in order to convert from milliseconds to seconds, you would the short answer is 2 divide by 1,000. Divide 1,000. Now let's look at an example. Say you want to convert 1,300 milliseconds to seconds. How do you do that? So again, you just write millisec, and then because you want milliseconds to cancel out during the conversion, and you know a second is equal to 1,000 milliseconds, so you would put 1,000 milliseconds on the bottom and 1 second on the top, and now the milliseconds cancel out with the milliseconds, and you have 1,300 seconds over 1,000. So you know that it is 1.3 seconds. And that's how you convert from milliseconds to seconds. Let's look at the sample solution over here. Here we have, yes, they just gave you the conversion, which is right over here, except they wrote it in a different form. So let's just say, good job. Oh, whoopsie. Good job. Don't know what's wrong with the mouse. Good job. That's correct. Solution is correct. Okay, now let's move on to our second problem. So the second problem is, what is the unit circle? So this is more a conceptual problem, and it's the unit circle. So the unit circle actually had some important trigonometric meaning and applications, but for your purposes, the unit circle obviously is a circle, and let me try to use this function so that it can actually include a circle that's more regular. Whoopsie. Okay, so this is the unit circle. The unit circle is called the unit circle because the radius of the circle is just 1. So radius is equals to 1. and radius is equals to 1. As a result, we know these 4 points on the value of these 4 points on the circle. So this would just be x equals 1, y equals 0. Oh, this is x-axis and y-axis. And this is just be x equals -1, y equals 0, x equals 0, y equals -1, and x equals to 0, y equals to 1, right above here. Furthermore, we also know that for each point, the x value is cosine and the y value is sine. So, for example, for the angle over here, if the angle is 90 degrees, so cosine of 90 degrees would be 0, and cosine of 90 degrees, sine of 90 would equals to 1. So the point over here would be the cosine versus sine, and for this specific angle. And same with the rest of the unit circle. So this is very useful for determining trigonometric values, the values of cosine, sine, etc. I have a full unit circle right over here. Let's move it towards our example. So this is the complete unit circle that I pulled from somewhere. So for example, you see right over here, if the angle is 90 degrees, the cosine would be 0, the sine would be 1. If the angle is 30 degrees, the angle is 30 degrees, so here this theta would be 30 degrees. The value of cosine will be √3/2, and the value of sine would be 1/2. You could also notice that right over here, the angle of 108 or 150 degrees. The angle here is 150 degrees. Here is 150 degrees. The x value, or the cosine value, would be -√3/2. The y value and this on the circle, or the sine of 150, would be 1/2. Notice that on this part of the circle, x is negative because x over here is negative, and y here is positive, and so the cosine value would be negative because the cosine value is the x value, and the sine value would be positive because sine value is the y value. So this is about all you have to know with the unit circle, and make sure you know how to find the cosine of an angle and the sine of an angle in both degrees and radians for this concept. But yes, that's the unit circle, and let's see what we have here for the sample solution. Yes, they basically explain the same thing we did with less examples, and they also have a graph over here. Perfect. Okay, so let's say this is correct. Great job. Yep. Now let's move on to our third problem. The third problem is, what is an acute triangle? It's another conceptual problem. So let's write it down. Acute triangle. Triangle. So acute triangle is just a triangle with 3 acute angles. So let's see here. 3 acute angles. And what are acute angles? Acute angles are angles with less than 90 degrees. Less than 90 degrees. So some examples of acute triangle, or let's draw some triangle, see if you know whether acute triangle or not. So first, let's draw an isosceles triangle. Is an isosceles triangle an acute triangle? The answer is yes, because all 3 of the angles are less than 90 degrees, so all 3 of the angles are acute angles, which makes the isosceles triangle an acute triangle. Now let's look at another example. Let's see, this is around 70, and this is around also 70, and this is 40 degrees. Is this a acute triangle? The answer again is yes, because all three of the angles is less than 90 degrees, so all three of the angles are acute angles, so it is a acute triangle. Now let's look at the other example. Oh. Uh, 20 degrees, 30 degrees, or sorry, 40 degrees. Is this a acute triangle? The answer is no. Why isn't it? Because the angle right over here is 120 degrees, which is more than 90 degrees. So this angle is not an acute angle. So this triangle doesn't have three acute angles. So this is not an acute triangle. So yes, acute triangle is just a triangle with three acute angles. And in order to find whether a triangle is acute triangle or not, you just need to check whether all three angles are less than 90 degrees. This is acute triangle. And let's look at the information here. Yes, they have some examples. Oh, they have the exact example as me. Oh, not the exact as me, but some of the same examples. Perfect. So let's say, good job. This is right. Perfect. Now let's move on to our next question. Oh, next question is, what is an obtuse triangle? Which is perfect. So obtuse triangle. So you know that an acute triangle is a triangle with three acute angles. And an obtuse triangle is a triangle with has one obtuse angle. And then what is an obtuse angle? An obtuse angle is just an angle that measures more than 90 degrees. So larger than 90 degrees. Than 90 degrees. So how do you know whether an angle? So let's, I guess, look at an example. So first of all, let's look at this example. Whoopsie. Hi. It's fine. So this would be 160, and this would be 15, and this would be 5 degrees. Is this an obtuse triangle? The answer is yes, this is an obtuse triangle. Why? Because this triangle has one obtuse angle right over here. This angle 160 is larger than 90, so it has one obtuse angle, which makes this triangle an obtuse triangle. Now you might be wondering, can an obtuse triangle has more than one obtuse angle? The answer is no. Why not? Because the sum of the angles in a triangle has to be less than 180 degrees, which makes a triangle can only have one obtuse angle. So the obtuse triangle just has one obtuse angle. Now let's look at the triangle we drew from the previous example. We know this triangle is not an acute triangle. Is this triangle an obtuse triangle? The answer is yes. because this angle right over here is 120 degrees, which is larger than 90 degrees, which makes it a obtuse triangle. Now let's look at another example. Is this triangle an obtuse triangle? The answer is yes. Why? Because we have an angle that's 100 degrees, which is larger than 90, so this triangle again is an obtuse triangle. Lastly, let's check whether this angle is an obtuse triangle. Whoopsie. And from here, we can see this triangle is not an obtuse triangle. Why not? Because none of the angles are larger than 90 degrees. So this is not an obtuse triangle. So no. That's all we're going to cover for obtuse triangles. And let's look at the sample solution over here. Yes, they also went over how to find the area of obtuse triangle, which is just base times height over 2, like all the other triangles. So what we're going to say, excellent. The solution is right. Perfect. And we're going to move on to our next example. Okay. So the next example is, how do you convert from centimeters cubed to meters cubed? Centimeters cubed to meters cubed. We know that 1 meter is equals to, or I guess 1 centimeter is equals to 1/100 is equals to, so 100 centimeters is equals to a meter, or a centimeter is equal to 1/100 meter. So in order to find the centimeters cubed, we just cube both sides. And we know that 1 centimeter cubed is equals to 100, or sorry, it's 10 to the power -2, which means 1/100 cubed meters cubed. And 1 cubed is just 1, and 1 centimeters cubed would equals to 10 to the power of -6 meters cubed. So we know 1 centimeters cubed is equal to 1 centimeters cubed is equals to 10 to the power 6 meters cubed. Okay, so this is our conversion. And let's see, yes, they had the same solution as us, except they didn't multiply the 3 with the -2, so they didn't simplify the answer as much as we did. So yeah, 1 centimeters cubed is 1/10 to the power of 6, or 1/1,000,000 meters cubed. So let's just say this solution is correct. Correct. Answer can be simplified. Solution is correct. Now let's move on to our next math problem. which is very convenient. It asks us, how do you convert meters cubed to centimeters cubed? So again, we just do the same thing, except we do it the other way around. So again, we know 1 meter is equals to 100 centimeter, or 1 meter is equals to 100 centimeters, or 10 squared, which is 100. So now we're going to cube both sides to get meters cubed. And we're just going to cube both sides. Oopsie. And we know that 1 cubed is just 1, and the meters cubed is meters cubed. And then 10 to the power of 2 cubed centimeters cubed. And we know 1 cubed, again, is just 1 meters cubed. And 10 to the power of 2 cubed is 10 to the power of 6 centimeters cubed. So we know 1 meters cubed is equals to 10 to the power of 6 centimeters cubed. Or, in other words, 1 meters cubed is 1,000,000 centimeters cubed. So this is our conversion right over here. You'd also notice that it's just the reverse of the conversion the other way around. Okay, so that's how we convert meters cubed to centimeters cubed. You just multiply by 10 to the power of 6. Yes, their solution is the same as ours. Let's just say correct. Yay! Now we're moving on to our next problem. So our next problem is asking us, how do we find the volume of a cube? So problem number 7, asking us volume of a cube. First of all, a cube is something that looks like this. A cube has 6 sides, and each side is a square. So this is a cube. It's a 3D. And let's just say each side is S, and all the sides of a cube is equal to each other. In order to find the volume, we just multiply the base times the height over here. And we know, since this is a cube, all its side is equals to S. So we know the base, which is the area of a square, is just S squared, and then times the height, which is also S over here, so it's just S squared times S. So the volume is just equals to S cubed, and that's the volume of a cube. It's just the cubed or of its side. And that's our solution of finding a volume of a cube. Now let's look at the sample solution on our left. So how do we find the volume of a cube? Again, they had a illustrative figure, like our figure of a cube. And yes, this is just how we find the side of a cube. And they also provide an example, which is a really straightforward example. So let's say wonderful. The solution is correct. Okay, let's look at our next example. So the next example is actually a practical application of our previous example. How convenient. So our next example is asking us the volume of a cube. let's just draw another cube for this question. It's not really well done, but we can, oh, whoopsie, we can work with it, right? So it's asking us a cube has a side of 16 square inch. And it's asking us what's the volume of the cube. So we know each side of the cube has length s. So the area of the cube would just be s squared. And we know each side would just be the square root of the area, which is, in this case, the square root of the area 16. So each side would be 4 because the side of a cube cannot be negative. So each side of this cube is 4 inches. From the previous example, we know in order to find the volume of a cube, we would just cube the side of the cube, like so. And we also know the side of the cube in this case is 4. So the volume of this cube is just 4 cubed, which is 4 times 4 times 4, which would be 4 times 4 times 4, which is equals to 16 times 4, which is 64. So this is our answer. The volume of the cube is 64. And don't forget the unit. It's 64 inches cubed. Inches cubed. Great. Now let's look at our sample solution. Yes, they did the same as us. And the volume of the cube is 64 cubic inches, or inches cubed. Okay, let's say correct solution. Yay! Okay, this is all we're going to cover today for this live stream. I hope you had a wonderful time, and I hope you learned something. Again, thank you for coming, and hope that you will join us for our future live streams. Bye-bye.